Greetings. We're going to be talking about reversing global heat with paleoclimatology today. My name is Dr. Tom Ballone from Integrity Research Institute, and I'm a general engineer, PhD, who's taught environmental science and physics and electrical technology at community college for years before becoming a patent examiner for a couple decades at the U.S. Patent Office. So we run a nonprofit organization here in the Washington, D.C. area, charitable organization, and certainly open to your support. What you see in the background is the Mauna Loa CO2 levels that have burst past the 400 parts per million level. Well, today we're concerned with reversing the global heat problem that we are all experiencing. And the two parts that we're going to talk about is ethics and morality as applied to the world and consequences of that. But the most important presentation is on the environment and climate change problem with a solution. And the solution, I think, is very important. Of course, we all should feel that way. Well, in terms of ethics and morality applied to the world, what I'd like to share with you is something that I've actually taught in environmental science years ago, and that is the Green Revolution. Well, the Green Revolution is single-handedly attributed to the miraculous work of Dr. Norman Borlaug, Nobel Prize winner, who then now became the subject of the man who tried to feed the world. And this is an important video. It's now available on Amazon Prime, and it's very frightening, edifying, as it says here. It was basically filmed based on the situation in 1950, around the time I was born, when only 2 billion people were in the world, but 1 billion of them were starving, mostly in India. And what you see in the video is the fact that all of a sudden he has mountains of hybrid grains that are so prolific that the world then had a new chance to no longer go hungry. But he warned everybody, he said, I'm only giving the world 20 to 50 years to really solve this problem, because unfortunately, when you feed everybody very substantially, then population starts to grow. And that's exactly what happened. What you're looking at here is the population rate growth, the rate of growth, which peaked around 1975. And luckily, it started to decrease after 1975 and continued to do so. But the important prediction from that is that the population size will max out around 2100, and that is basically at 11 billion. So 100 years later is what we're specifically describing as the difference between rate peak and population peak, or systems peak, if you want to look at systems engineering. The takeaway is that the global population has tripled since 1950, which has been an extraordinary shock to all of us who were born in that time. CO2 emissions as a result have quadrupled because of the same number of people growing so rapidly. And then energy demand has quintupled. Well, this is a huge stress on the environment, as you can imagine, and that's why everything is heating up. Environment and climate change is the biggest topic we're talking about now. Well, unfortunately, the Columbia Glacier has disappeared in only 6 years. National Geographic surveyed 18 glaciers throughout the world and published this in 2019. And actually, this is since 1980. Many glaciers have shown this kind of severe loss. And this is happening around the world. We're going to be glacier free maybe in our lifetime. That's how bad things are, except for Antarctica. That's going to take a little longer in Greenland. But the rising temperatures in the north are going up twice as fast. Arctic temperature in blue, global average is about half of that. And the important part is that as the Arctic ice is melting, we basically have albedo problems, and that is the water absorbs heat, the ice was reflecting heat. So that's a compounding factor we have to take into consideration as Russia tries to bulldoze its way through the water that's now appearing more and more often. It'll be ice-free very soon, within the next decade or two. And as we see carbon dioxide emissions worldwide, we basically have a dominant, very dominant 70 to 80% of fossil fuel burning, gas, oil, coal, only renewables way at the blue bottom here. This is a serious issue that hasn't been solved even as renewable energy keeps growing worldwide. It's very good that renewable energy is growing because in the long term, that's going to solve the problem. But I want to talk about the short term because things are getting too hot. I think everyone should realize that things are getting too hot and we have to do something now to prevent the serious growth of heat that I'm going to show you immediately. Okay, here's the world paleoclimatology lesson 101 from a million years ago. Okay, carbon dioxide up and down, up and down. And then the ice ages around 400,000 years ago started to get very regular. Every 100,000 years, we went through an ice age, another ice age. And then finally, it started to heat up um, to the level of carbon dioxide that the world never saw before today, and that is 300 parts per million. Except for around 50 million years ago, there was what's it called, the PETM, that actually had a higher carbon dioxide level. And that's another whole history lesson that's very interesting. We have an expert here in the Washington, D.C. area at the National History Museum who gave a lecture on that. But back to the important part here is that, boom, humans decided to experiment. Oh, what if we push it up to 400 parts per million? Is anything serious going to happen? I don't know. I don't think so. We're still riding in our cars and we're using air conditioning. Well, the air conditioners are 2 billion now, and we're expected to buy another billion worldwide within the next decade. And this is a serious acquisition problem worldwide. How can you pay for all these air conditioners? Okay, go to climate.nasa.gov if you want to see this up close. However, the past 400,000 years was graphed and published in 2006 in MIT's Technology Review. And this is an important graph, so shocking and amazingly edifying to me that as I looked at it closer, I was seeing CO2, temperature, and sea level all tracking each other, all tightly correlated. And luckily, Dr. Hansen actually provided a graph, a table of this graph that included the CO2 values, temperature values, and sea level values. So as I examined it more closely, and then publications started coming out a couple of years later, it said 4 degrees was going to be the goal of the Earth, and 6 degrees Fahrenheit. I started to get worried and say, well, maybe he's right. And then I started publishing articles. I've published this one and many others, over a dozen articles now worldwide in various journals, talking about the projected 6 degrees C. Now, why am I saying 6 degrees C? I'm going to explain that in a second. But thousands of people have seen this, and the basis of it is simply the Hansen graph, which now you're looking at my annotated version of it. Well, Dr. Hansen gave these nice little graph lines that also indicated the 290 or say 300 parts per million as being the maximum, which now, unfortunately, we review as a baseline. This is now our baseline where we're starting from. It used to be the maximum we would stay under, and now it's the opposite. So that's what we're doing to the Earth. We're inverting everything that it's normally used to, and we're seeing what the attic is going to look like. Well, the attic is full of carbon dioxide, and we're just keeping pumping it up there more and more. But the important part is, what do we have currently? 420 parts per million, way above the 300, at least 40 some percent higher. And when you look at 420 minus 290, or say 300, we get about 120 parts per million of excess CO2. And when you look at the key I created, which was very easy because you just take the maximums and do the ratios, 20 parts per million equals 1 degree change worldwide. And so you divide your 120 by 20 and you get 6. So this is the 6 degree change that we're indebted for. We're locked into 6 degrees hotter, 10 degrees Fahrenheit, no matter what we do, even if we stop burning fossil fuels tomorrow. People don't realize that. National Geographic realized it, however, and that's why they made this video. 6 degrees could change the world. Why 6 degrees? Because, as I just said, 20 parts per million excess equals 1 degree indebtedness. So if you have 120, you're in debt for 6 degrees, no matter what we do, unless we get rid of the parts per million, 120. And guess what the 120 really means? Multiply by the conversion factor, it's 936 gigatons today of excess CO2 above our ignorant heads. Why do I say ignorant? Well, ignorant comes from the word to ignore. And that's exactly what we're doing. We're ignoring the problem as we have 1,000 gigatons, 1,000 billion, in other words, 1 trillion tons of CO2 above our heads, which we think because it's transparent, we should ignore it. I mean, that's what Elon Musk and Trump actually said on their conversation this week. And the New York Times did a summary of their comments. Well, Elon Musk said, "Oh, we can ignore it because it's only when you get to 1,000 parts per million that you have to worry." Yeah, it's called cognitive impairment, among other health issues. We can't breathe CO2; it's a poison, but he thinks it's okay. And of course, this is the problem when leaders like that are telling us falsehoods, then we tend to believe that we can just sit back and relax. Well, that's like frogs in a boiling pot of water that's slowly heating up. And we know what happens there. 6 degrees could change the world. Go on YouTube, look at this video, seriously evaluate how hot do you want it to get, and you'll be happy and tolerate it. How many fires, how many droughts, how many starvation worldwide. The film runs through the effect each degree in temperature change has on the world. Very, very important. You have to realize 1,000 gigatons is the number that we're looking at today, and keep adding 40 gigatons every year. Okay, you got it? Good. Well, the important part too is, yes, we're adding 40 gigatons each year. Back in around 1950s, it was only 10. 1980, about 20. 2000, it was only 30. Well, now it's up to 40. And it keeps climbing, and that's what the Hawaiian Mauna Loa monitoring station tells us. NOAA has monitored this for years now, for decades, and this is the latest data point that's inserted to show 2.5 parts per million being added every single year of CO2. And the rate, which is very important, as I showed with population, is a predictor of what the level is going to be when it finally stops and starts declining. Well, if the rate hasn't reached a peak, the level is not peaking and is not expected to peak for at least 100 years. That would be a systems approach analyzing this phenomenon, period, with no emotional attachment to what the results are. We have to see the rate of CO2 emissions stop and start to decline before we can even anticipate CO2 itself stopping and declining at least 100 years later. Okay, so now you got the facts, and what can we do about it? Well, global climate change, unfortunately, a report that just came out this month says we're now trapping about 1 watt per square meter, which is the new heat trapping imbalance, and it's twice of what it was only 20 years ago. Well, if this heat trapping that 1,000 gigatons is doing to us, and it's twice of what it was 20 years ago, what is that going to be 20 years from now? We want to think about it. And of course, IPCC is basically identifying this as a big problem. We should get rid of carbon dioxide, carbon capture and storage, very important. Even 20 years ago, this was identified by IPCC. But see, IPCC is a corrupted organization. Very few people know this. Fossil fuel industries are on the board of IPCC, and they're the ones that contribute to the summary, which is what 90% of the people read. I'm quoting from an article that was critical of what IPCC has been disseminating to the public. And this was a shock to me, and I started to distrust the numbers that IPCC has been spreading to the world, because you'll see, as they talk about gigaton removal, they're not telling us the whole facts. Well, Project Greensand is one good company to look at for hopeful progress in developing and evolving toward carbon dioxide removal, CDR, and direct air capture, DAC. They're in the millions of tons per year, capable of reaching it, in other words, and they're burying it 1,000 meters below the North Seabed. And that's important in the very important long-term storage area, because it'll form carbonates, carbonate rock. Carbon Capture, Inc. is another good example. Megaton direct air capture. Hopefully this is going to be a big solution as well in Wyoming. And here we have the IPCC summary that I grabbed, and here's the director, Dan Lashoff, and the World Research Institute. Uh, this is important because they're basically watering down the facts, 2 gigatons per year maybe, and possibly getting up to 20 gigatons by 2100. This is all falsehoods, because if we're putting up 40, why would you bother to even talk about 20 removal when it won't even get more than half of the problem? John Kerry is telling us the truth. Even if we get to net zero, we still need carbon removal. But the gigaton scale is in small print. And that's exactly what I want to address and emphasize to this population, this audience, because we need billionaires in Congress and world leaders. Because if you look at COVID, that was just a trial run. That was something that went away and would go away. And we were hoping this would happen fast, and it did. But the climate change problem is not going away, and it won't go away very quickly unless we do major geoengineering. Okay, well, this is actually possible. And that's what I want to convey to you. This is possible, folks. Metal supercharged methods are available to bury billions of tons. Gigatons equal billions of tons, same thing. Harmful carbon dioxide, get that under your brain. Harmful. And we're putting it under the sea for centuries. University of Texas at Austin. And there's plenty of others. These are titles of my journal articles that I published, removal of gigatons. And there's lots of, like X Prize Foundation that have given away $100 million. And of course, the various journals that get this information still may not be reaching the people that can actually do this at the level that's necessary to have an impact. Oceans can be used. There's plenty of very exciting gigaton scale work being done in this region, even in the past couple of years, floating gigaton level of removals. And it's interesting when you get into the physics of it, which I won't hear now, to understand why would you have it floating, why is it on the ocean, and how effective is this? Captura is another company that's doing this. That's the one that has the floating modules. Well, all of this is very important, but we need to look at the cost, of course. The bottom line is most important. Vesta Earth's doing good stuff. Climeworks is my hero. I'll explain why in a second. And the alkaline molecules, bicarbonates, that's what we want to aim for. But $25 a ton is the lowest price you can find when you do all the research across the board of every single gigaton level of removal, even in megaton levels. Still, the important part is, what is the bottom line cost? Well, my goal, I'm suggesting to you, to the public, is $1 a ton. We have to get to $1 a ton, or at least maybe a couple dollars a ton, because at $1 a ton, then you're talking $1 billion for 1 ton, 1 billion tons, and 1 gigaton, in other words. So that's doable, it sounds like, because then it's $40 billion for 40 gigatons. And that would be every single year we'd have to spend that just to break even. In other words, you're putting up 40 and you're removing 40 together, and at least it stays at the level of carbon dioxide that we have now. However, that's not even tolerable either, because we're at 2 degrees change. We've exceeded the 1.5, in case you don't know, but we're at 2, we're headed for 3 very shortly in the next decade. And when we get to 4, 5, and 6, you'll see from the video of National Geographic, it's intolerable, it's horrible. We don't want the 3, 4, 5, and 6. We don't even want the 4, 5, and 6. So that means big deals of hundreds of gigatons removal. So we have to learn how to do at least 1 in 40. Okay, lots of technology can do it, CO2 splitters. These are very fascinating methods for gigaton removal. DasterEnergy.com aims at 5 gigatons per annum, 10 gigatons later on. At least they're talking in the scales that we need, and very exciting that carbon capture is now being discussed as it was not being discussed even 10 years ago. Here's my Climeworks suggestion for you, and that is climeworks.com has the not only technology to do it, but also subscriptions where the public can support their work. And this is 1,000 times more effective than trees on the same land. So keep that in mind. Trees can't solve the problem. 1 billion trees, which South Korea planted, only will trap it for 100 years, and then the dying trees give it back to the atmosphere. So trees are not the solution. Direct air capture is. And here's the size of their construction even 2 years ago, and it's growing by leaps and bounds. So they're the most serious company in the world that's looking at, and they started in Iceland, actually, very exciting. So I emphasize as they finish up at 40 gigatons of CDR per year by 2030 should be our goal, has to be our worldwide goal, if we want to survive, in other words, and 100 gigatons of CDR by 2050. And these are very aggressive goals, but they're reachable, they're possible. And then we actually are looking at cutting back on the 936, that is the excess heat trapping problem that we have right above our head. The elephant in the china shop that's causing so much trouble that we can't see because it's transparent, but it's definitely trapping the heat and causing excessive record heat every year. They're talking about Olympics that basically we won't be able to have outdoors anymore. I mean, let's not talk about the horrors. Let's do something about it. And I hope you will learn from this lecture that we have to do something right away. Thank you.